So with that overview, I would like to get started at taking a peek at the software. And this particular study is a hopper, and I had been working on it for a customer just as a quick analysis. And we said we want to play around with, what are the loads and deflections due to wind gusts over the structure. And so in this study, we're going to take a look at the interaction between structures and flow, and also show you how we build up the model from scratch. So we have a hopper loaded up, and we'll notice that there's a flow simulation command manager at the top of the screen. And then to our left, our flow projects are sorted by SOLIDWORKS configurations, and then we can have multiple flow projects under each configuration. So we're looking at a 60-mile-an-hour gust model. And with all of our simulation tools, inputs are on the top and results are on the bottom. So we have flow trajectories displayed right now. And the contours of these trajectories are representing velocity, and any parameter within the governing equations for flow simulation, pressure, density, temperature, velocity, forces, and heat, we can quantify and plot those parameters. And as you can see, we don't even need to go back into the dialog box to make that tweak. So the goal of this simulation was just to blow 60 mile per hour air over our hopper, and then let's see what are the pressure loads under our structure. I can also look at my results in the form of surface plots. So here we can do contour plots on the geometry of the pressure, and this is what's going to create the forces for deflection. And then we can look at cut plots on top of that. So in particular, this cut plot is showing velocity on top of the pressure plots in the structure, and then we're looking at flow streamlines. And I can animate this, and it's just going to walk across my computational domain. So as you're looking at the screen, you might have noticed that there's a whole slew of simulations at the bottom of the screen, and these are coming from Simulation Professional or Simulation Premium. And because our products work and play well together, I can switch from flow over to structural analysis, and we'll look at our base model. And once again, top to bottom. So on the top we have material definitions and our cut list and our parts from our weldments. And then as we walk to the bottom, we see we have fixtures keeping this from blowing away. And then I have pressure loads automatically transferred from flow simulation. And we'll just display the fluid pressure as a quick preview. So this is the pressure as it's mapped from the flow analysis to the FEA mesh. And now we can take a look at stress and deflection. So we're looking around 15 megapascals of stress and less than half a millimeter deflection. Our hopper is actually relatively short, not too large, and it looks like relatively streamlined. So let's say we want to make some design changes. And SOLIDWORKS simulation, because we're integrated, it's very easy to take a simulation that we've already created and apply that to another version of the model. So I do have another version of this model. I was actually a little concerned. It looked like the displacements were kind of low. I wanted to see, what if I make this a worse condition? How does that compare? So inside the same model, I have, let's say we want to put our company's name on the side of the hopper. I can just activate the SOLIDWORKS configuration that the simulation is linked to. And we see I have the wind coming from the Z direction now, and I've just got a plate with a reinforcement in my weldment structure. And once again, we can look at stress and deflection. And the stress results are not too terribly different, a little bit worse because we put our a big plate on the model. So 16 versus 15 megapascals, but still a pretty high factor of safety. And then our deflections were slightly increased. And then we can extend this simulation from here and start playing, what if scenarios. What if all the bolts aren't bolted down? What if we have one loose? So we can go in and start to tweak our fixtures. Or if I have a particular stress hotspot, I could go into the model and put in edge weld connectors and start to verify the strength of my welds. And you see, with all of our tools, we have the options of duplicating these studies and bringing them over to another CAD configuration. So how did we get here with this model? So this is pretty cool stuff. And I would like to build a flow simulation model here from scratch so we can get a feel of all the feature functions that are available in flow simulation and what the general model build process looks like. So I'll switch back to my original configuration for the model. And I'll jump into my flow simulation command manager. And this has a nice wizard that helps to get our flow simulation model started. So we'll call this 60 miles per hour on the web. And it asks us which config to use, so we'll use the current. And then from here, what I really like is, all modern sim tools, at least everything within SOLIDWORKS, we can mix and match units and pressures. So I want to look at my pressures and PSI. And then I'm going to be specifying velocity, and I'm thinking today in terms of mile per hour, so we'll choose that. The next phase we choose, is this an internal or an external analysis? It's external, we're blowing air over the object. We'll work on the internal analysis next with the thermal. And here we can choose to make it time dependent or steady state. I'm going to go with the time dependent analysis. And then we can turn on gravity if we're looking at thermal and buoyancy. And then we move to the next step. And that's selecting the fluids that are in the model. So in this dialog, we can select from all the fluids that are in our standard database. So we'll start with air. And if by chance this was completely submerged underwater, we might want to use liquids. And we can get into compressible liquids and non-Newtonian fluids, in addition to real gases and steam models. The flow is going to be under Mach 60 miles an hour, so we're off Mach by about an order of magnitude or so. And we'll allow the software to make its laminar turbulent decisions based on its internal calculations. And we won't include any humidity. If we needed to include a custom model or a custom material, we have a flow engineering database that's going to keep track of all that information. So once we add one, we can keep it around for posterity's sake and for reuse. And this would be the new button, and this brings up our engineering database. We set up wall conditions. So it's an adiabatic wall, meaning no heat is coming or going from our environment. And now we set initial conditions. And for an external flow problem like this, this is where I can define our velocity in the negative x direction of 60 miles per hour. In meshing, it has been really simplified. That is one of the biggest CFD headaches. And SOLIDWORKS simulation has done our best to reduce everything down to pretty much a slider. And in addition, With the external flow model, I'm going to show you how we use auto or adaptive meshing to easily refine the model where it needs to be so that we get good, accurate results. So once I hit finish, this is going to set up my base flow model. And the box we see around the flow model is what we call our computational domain. So this is where we're doing all the calculations. I can take this domain, and since I don't need quite as large an area around the part, my flow is coming in from the positive direction and going from right to left on our screen. So I can shrink the domain a little bit. Now I'm good to go. So this is a reasonable size to capture the information we're interested in. I can then hide this domain so we don't have to look at it again. As far as boundary conditions with an external flow model like this, we're pretty much driving the flow with that initial condition. So the next items that I want to define in the model is what do I care about. So in this case, I care about the forces on the faces. And with SOLIDWORKS flow simulation, we create goals. And these goals help the solver decide what's important during the simulation solution. And also, we can extract this information very easily in addition to grabbing local information from surfaces after the fact. So we're going to define a set of goals. And the first set is just going to be the forces on these surfaces. And I can filter. I selected all the faces in the model, and I can filter and remove faces that aren't touching fluids. And then I will move down and select the parameters of interest on these faces. So I'll pick the magnitude of force and the X, Y, and Z components. So now I can extract this information while we're solving and then compare it between configurations very easily. And I'm going to set one more set of goals, and these are going to be global. And I'm going to ask the model to tell me the max, min, and average velocities during the solution. And there's one last setup for this flow problem, and it highlights a very beneficial feature. You know, with flow and the turbulence and eddies that occur after the structure, I'm not exactly sure where I would want to refine my cells or my mesh. And with SOLIDWORKS flow simulation, we can set automatic refinement, which basically what this does is it splits our flow cells automatically during the solution. And we can define how many times we want to split those cells. So level 1 means we split our cells once, 2, 3, and 4 means we split them again and again. And then we can also tell the software how often we're going to split the cells. And here's an example. So this is a video of the solution. And the gray items are the cells. And we'll see that as the model is solved and the high gradients of pressure or velocity are being created, our cells are splitting in the areas of these high gradients. This way we don't have to know exactly where we need to refine the model. We can set on a refinement check so that it checks in with the simulation every number of iterations or every few time steps, and we'll remesh the model where we need to get the refinement. So we would, in that case, I set the model at a level 3, and then I had it periodically refine the model. And that is the basic model setup. And if we want to apply this, let's say, to the other CAD configurations in the model, the billboard, for example, similar to the structural simulations, I can just say clone this project. And then it's going to say, which CAD version do you want me to clone this project to? I can then select from any of the configurations in my model and then duplicate what I've just created. So it's the general flow model build process and an overview of some of the general capabilities. And let's kind of switch gears